Hi, welcome to Meshparts. This video demonstrates the steps through the construction of a structural assembly made with aluminum profiles. The finite element model components we see in the graphic is a Bosch rod. Meshparts have the capability to construct assemblies with finite element model components. The process does not require any CAD geometry. There are pre-processed finite element models in the online library. Those can be dragged right into the assembly. First, we must choose the target location for the assembly in the file directory. Then we select the new assembly from the context menu, rename the assembly per choice, and open the assembly. This will open an empty assembly. We can use finite element model components from the Meshparts cloud library. Meshpart has libraries for standard and manufacturer specific components. For this example, we will use Bosch Rexrod's aluminum profiles. We can see through the existing models and select one. Then we drag the model into the assembly. We can drag single or multiple components. The components are parametric. This allows us to configure the model as and when required. For this example, we need an aluminum profile that has an inclined end condition on both of its ends. This can be achieved using the angle parameters. We must position this profile in the global space coordinates. Now we can drag the second component of choice. For this case, the same profile model comes again. We can copy paste or duplicate the existing model. When we have multiple components in the assembly, we can define position constraints. There are predefined nodal sets available for the models. We can select in the model tree or right on the viewing area. Selection filters are available for ease. Nodal sets are the most robust way to define load boundary conditions. They are stable and common among similar finite element models. So replacing components in the assembly keeps the load boundary conditions stable. However, there are other choices for defining boundary conditions. The components' local coordinates, surfaces, points, and curves can be picked from. Definition of boundary conditions are listed in the model tree. We can configure the conditions to fit our requirement. Proceeding further, we can either copy or duplicate existing components. Duplicating fetches the load boundary conditions along, which might or might not be beneficial. When too many components clutter the view, we can choose to show hide components. For this, we must select and drag the component from model tree to show only the selected ones. After the new components are placed in space, we can parameterize the connection properties. For this, we must define the parameter in the assembly equation section and then call the parameter where it is needed. This way the whole model can be constructed. Two matching components necessitates a connection between them. Definition can be done from the context menu or from the assembly frame as they appear when selected. The properties are readily configurable. Once the assembly is ready, we can use this assembly as children to another assembly. We finish the pre-processing by defining further load boundary conditions. Those are required. There is provision to apply force, displacement, and thermal loads. Properties of joints are configurable. Load steps and time steps can be adjusted in their respective frame. The whole construction process needs no CAD data in the entire process. So in complex assemblies, a critical location may not raise a question of meshing errors, because the components are already meshed from before. All we need is to solve. We want to see the deflection plot of the aluminum structure. The lower end is fixed and a model analysis is performed. For this reason, we have to select the CDB file in the Explorer and choose the Visualize Results from the context menu. In the assembly frame, there is a table called Results Sets. This table lists the sub-steps of the result. This is a model analysis, so each of the sub-steps here is actually a mode shape. We can select the rows of the table to see the corresponding deflection plot. In the results quantity table, we can further refine the plot for the results in a specific direction of choice. The play button below is for animating the result, and the reset button restores the model to the pre-processing view. There is a deformation scale drop-down list to choose the scale of the plot. Besides these, Meshparts also have option to create an HTML report of the model. We can see the deformation plot and virtual reality result opening the HTML file in the browser. Thank you.